Hello everyone. So this is the data science resume that I use to apply to different jobs, and these are the skills that I have right now. I'm doing a internship at intern pay, so I have included that. My my resume generally includes this K-means clustering, customer market segmentation using techniques like K-means clustering and hierarchical clustering. So it is in my skills. So today I wanted to make a project out of this for demonstration purpose that I know this particular skill or algorithm. So I just made a presentation out of that. Let's go to the presentation and we'll see. So this is the presentation of customer segmentation using K-means clustering. I will be using K-means for today's project. So my name is Ishan Agarwal, so it is written there. Now, what is the problem statement we have? We'll be discussing about problem statement, the data we have, and how to approach the solution. The Jupyter notebook code explanation, like why I did a particular step or how I approach it, how to I did the customer segmentation or clustering, and then how we can plan this for scale. So at a bigger company or any clients or any company's growth. So we have the problem statement here. We have data of customers of a shopping mall. The data set generally consists of the customer ID and the age, gender, annual income of that particular customer, and then the scores. These scores are personal to that particular customer based on the activity or if he's a highly active customer based on his how he interacts and how he comes to the store. It is related to that particular person only. Then what we want to do, we want to target these customers and show relevant products to them according to different data we have. So how to approach the solution? Here we can somehow group or make clusters of the customers based on the data we have. So clearly, if you think once at this, people with higher annual income will be shown costly products. Why show them cheap products if they can just buy at a high costed products? Then people who have higher scores can be treated differently. So if you are this video, then I'll tell you one more video that you can see on YouTube only. So it generally describes or that person particularly tells how he has used that particular data for his a big market and he's a big businessman. Then we have a differently aged people prefer different products and services. So different age people generally think about different products, they need different products. So that's why we can somehow make clusters or make groups of them. Now we'll go to this Jupyter notebook code that I have with me today. So yeah, so starting the code, now I have imported some libraries that I'll be using such as NumPy, Pandas, Matplotlib for some visualizations and then Seaborn also. Then we'll be using a datetime. So I just downloaded datetime also, sklearn, then standard scalar, key means, and sellout analysis for this score. Sorry. Then I have already downloaded this small customer CSV file, which consists of the data. So, yeah, here we have the data with us. This is customer ID. We have a 200 rows there, 200 customers data. Then we have their gender, age, and income, and then this is a spending score. Now let's go to the next step. Yes, so here we will not be taking into consideration the customer ID and the this gender for this clustering. So we'll be taking a new data set that is required TF that will be taking age, annual income, and spending score only. We'll be doing some visualizations for this all these things. See, one more prerequisite for this clustering algorithm claim is clustering that we have to treat or remove the outliers. The outliers shouldn't be present. For seeing the outliers, we will be using box plots. So I have made the box plots for all the three this features. So you can see there is a outlier for annual income. We'll remove this, and after that only we'll make this project. This is a box plot for spending soul. Sorry for this train sound coming from background. This is a required data frame, that's info. So we have no null values, only 200 rows, all integers. With it a describe thing to see how the different quartile ranges or statistics there. Then mall, we can see from this annual income box plot that we have some quantity that is bigger than 120 and showing the outlier. So I just try to make it like this. Sorry, yeah, this. So we have 126 and 137. 126 is the maximum range but not an outlier, but 137 is an outlier. So we'll take the same data frame, that is required df, and we'll take all the parts which is not equal to 137. So we have only 198 non-null, so two rows will be deleted. So now we have already have our outliers removed. Now we need to do some scaling on this because it is important that whenever you make machine learning models, then you make some scaling out of that. So I have made a standard scaler, use that, then fit transform. Now I have some arrays. So I made a data frame out of these arrays, set a column for those, and we have scaled data with us for this model building process. Now start with the model building. Here I have set it for, I'm just making an arbitrary k number of clusters, taking four, and then made a this model, and this is the labels for that. But we'll not do this further. We will have to find something more relevant, more optimal, and more right, more experimental. So there are in k-means clustering. There are two things that we can either take use of this elbow curve, where I'll show this. So we can take use of two things: elbow curve and Salute analysis. So first, what we do, then we take some cluster ranges, different number of clusters. For clusters in cluster range, we will k-means, we have defined as k-means instantiate, or this n number of clusters will be clusters, and a mix iter we am setting 45. We have set we have fit, sorry, with the required df it's scaled. Now we are finding this k-means dot inertia and putting it inside our SSD. So we will be getting something kind of a list, and we have plotted it. So you can see in the plot, it is not 0, 1, 2, 3. It's not like that. It is 2, 3, 4, 5, 6, 7, according to the number of clusters. And we have to see a point which after which we shouldn't add any cluster. So here to here it has decreased very fast. It is a little bit slow here. Here again it has decreased very fast, and after it is increasing a little bit. So we don't want any increase. We just want the least possible distance or the least number. So we will take 2, 3, 4, 5, 6. I have taken 4 also into consideration, or I think 6 will be better, but we can't highly rely on only one process. So we'll do again sell out analysis. So that's why we just downloaded or imported that sell out is score from sklearn metrics. So we have again cluster range, clusters in cluster range, this k means, and we got these labels. Then we take this sell out average, then this is score, this is our data frame that we have, and this is our labels. So after that, what you see is this sellout score for number of two clusters is this. Now what we want the highest number of sell out this score. If you don't know the algorithm, I'll somehow after some time will make another video on that. But here what we can see the how highest sellout score is for n number of clusters equal to 6. So in this way it is like like double verified that we can take 6. Now we are making another model with n number of clusters equal to 6. So here we have different labels, k-means labels for our clusters. Now remember that we I removed that 137, that is outlier rows, from only these three columns, but we need to remove it from main data frame also because we don't have tables for that. So I have taken this data frame from main data frame, removed 137 outlier number rows, and we have 198, this 198 total rows. Then I added a new column cluster ID and k means labels to them. So finally, we have a data frame in which we have different customers and they all are particularly put it in a group, like six groups, six clusters you can say, that we have already discussed. And how then for I in more new data frame cluster ID dot unique. So here what we have, according to different cluster IDs, we have different cluster IDs according to different customer IDs. I didn't say something wrong, I think so. But now after all this algorithm, what we have now, we know that all these customers actually belong to a particular cluster only, so they can be grouped and together, and they can be marketed different products, they can be shown uh, in the same way or in somehow same kind of situations. So that is a good thing. This kind of information a mall manager or any business can understand and use it for future purpose. So this is all we have today. Thank you for watching this video. Then let's see if any of my, yeah, how to do it as scale. I think so. It is left. Yes. So I had a very small data set because I don't have so much compute resources right now. But we can make a some storing this data set in a storage systems like SQL or any cloud. We can make a create a pipeline where customers will be automatically getting segmented and will be shown different products automatically. This I don't know. I'm not aware, but this is what I know, and it can be done. So I'm just stopping this video and enjoy. Thank you.